For this one, we are looking at solving a quadratic application. Let's read through it. A rectangle is 5 inches longer than it is wide. Find the dimensions of the rectangle if its area is 84 square inches. We have previously done a problem where it was also talking about a rectangle, but it was asking for perimeter. So this is the major difference between these two problems. This one clearly is asking for area or discussing area. Okay, and so what is the area of a rectangle? We need to know that. And I write it as A equals L times W, but I'm going to tell you for the purposes of this problem, there's some benefit to writing it as A equals W times L. And you're going to see here in just a moment why. Let's plug in other things we know. We know that our area is 84. So this is going to be 84 equals W times L. Next, I need to create a different equation. And again, this is similar to the perimeter problem. So I need to know the relationship between the length and the width. And that is where the first sentence is coming in. And it doesn't actually say the word length. It does say longer than, but the length is kind of implied here, as in it's just assumed that you understand this is what it means. Okay, so a rectangle, you can kind of say a rectangle's length. So we're going to say L is going to be our equal. And then we have 5 inches longer than it is wide. So I like starting at the end of this sentence and working backwards. So this is going to be wide. We always want to put our variable part first. Now notice this doesn't say like twice the width. So this is just going to be W. Then we're going to figure out what goes here. We've got longer than. That's going to be plus. If it said less than, you would do minus. And then the number 5. So this created the equation L equals W plus 5. And that is what we need because we need to replace one of these variables, either W or L, with a different equation or a different expression so that we have an equation all in the same variable. In this case, it's going to be all in W. Okay? We did a very similar thing with the perimeter if you go back and review that. All right. So let's do that. So we have an equation for L now. So this would be 84 equals W times L. L is W plus 5. So that's going to replace here. And now you see why I put the W first. You don't have to, but we're distributing here. Okay, so we're going to do 84 equals W squared plus 5W. Now, at this point, look and see what kind of equation it is. We have a W squared. That means it's quadratic, and we've got to go through the process of solving a quadratic. And again, this is the setting it equal to 0, factoring, setting those factors equal to 0, and solving. So that's what we're going to do here. Again, you don't have to always have the equal sign or the equal 0 on the right-hand side. Okay, so that means that what I would typically suggest is wherever your W squared is or your variable squared, if it's positive where it is, keep it where it is and move everything over to it. So we want to move the 84 here, and we're going to move it over on the right side so that our 0 is on the left. So this is 0 equals W squared plus 5W minus 84. Now we have a trinomial that we can factor by grouping like we've done many times before already. So this is going to be W squared, add two blanks, minus 84. Let's figure out what goes in the blank. So I'm coming all the way over here. Actually, I'm going to do it on the left side. We want to do A times C. A in this problem is 1. 1 times 84. 1 times negative 84 is negative 84. And we want to multiply to negative 84 and add to 5. Okay, so what are our combinations of 84? Well, I don't know. Let's figure it out. 184 clearly is not going to give me 5. 84 divided by 2 is 42. 84 divided by 3 is 28. 84 divided by 4 is 21. 84 divided by 5 doesn't work. 84 divided by 6 is 14. So you're kind of constantly keeping in the back of your mind, ooh, I need a 5 in here, right? The difference would be 5. Why am I doing difference? Because the 84 is negative. So they're going to be different signs. 84 divided by 7 is 12. And I think that's where we can stop. So let's double check our signs here. Our add to our B here is positive 5. That means that the 12, if I've got 7 and 12, my 12's positive. But because 84 is negative, the signs have to be different. So the 7 is going to be negative. So we're using negative 7 and 12 in our blanks. And I, again, recommend putting the negative version or the negative number first. So we've got negative 7W plus 12W going in our blanks here. That's going to give us our 4 terms, and then we can group. So we're bringing down our 0, and we're going to group these 2 and our last 2 together. Let's factor out what's in common. So in common in the first group is W. Let's divide by W here, and that's going to give us W minus 7. In the second group, a little hint here, you want the parentheses here to have a W here, and the thing that's keeping it from doing that is the 12. So let's take 12 and see if it goes into 84. 84 divided by 12 is 7. And so that is going to work. So what does that mean? That means that our GCF is 12. And this goes back to always look at the smaller number or smaller, right? And so 12 does go into 84. 12 is going to be our GCF. That means I'm dividing by 12 both places. That means this is going to be W minus 7. So now we have W plus 12 is our first factor. W minus 7 as our second. Set each one of those equal to 0. So W plus 12 equals 0. W minus 7 equals 0. Solve. Minus 12 on both sides. That's W equals negative 12. And add 7 on both sides. That's W equals 7. Okay. Let's think about this in the context of the problem. So the problem is talking about dimensions of a rectangle. What I just got out was 2 possible widths, but I need you to consider this is an actual like rectangle that you can measure. So if we're talking about width, clearly we do not want the negative version of this. So our width is not going to be the negative 12. It will be 7, and this is 7 inches. That takes care of the width. How do we find the length? We're going back to this length equation that we have up here. So I do think that it is helpful for you to write the length equation. I do have a lot of students that just kind of go straight to putting it in and plugging it in, and that's fine. You just got to know what to go back to whenever you find the length. So we're going back to the length is W plus 5, and we now know our W is 7. So the length is going to be 7 plus 5, which is 12. So here, our length is 12 inches. I do want to make a quick note here that, yeah, I know that the width that we crossed out is a negative 12 and the length that worked is 12. And I do have some students say, well, isn't it just the other width and that becomes the length and you just take the negative sign off? And the answer to that is no, not always. Okay, so just be really diligent that that's not what you're like defaulting to, because it does not always work out like that. You do want to go back to the length and plug it in. And again, I would write this out so that you know what you're plugging into. All right, so we have our width. Our 2 answers would be width equals 7, length is 12.